Nowadays, our lives depend on electrical devices for many tasks such as cooking, reading, or even washing. But do you know how they work? What are they made of? And the dangers they may cause? This video explains you the following questions.
A standard plug, in order for it to work safely, 3 cables are needed. The live wire carries the current at high voltage into the circuit. The neutral wire closes the circuit and carries the current out of the circuit. The earth wire is essential to the circuit because it is a safety precaution if there is an excess current in the machine. The live wire is generally brown. The neutral wire is generally blue and the earth wire green and yellow. The live cable is equipped with a security. The security is a fuse. If the fuse breaks, the current stops flowing. The fuse will break if there is an excess current flowing into the circuit. It's normally caused by cables lacking insulation. Normally, the insulation keeps the heat inside. With the insulation gone, the heat increases and causes a fire. Another risk is direct contact with the metal inside the cable. Indeed, if the cable is connected, the electricity flows. Any contact with the metal will cause an electrization, the action of electrifying, or even an electrocution, die from electric shock. The same consequences happen when a plug is stripped from its own insulation layers. In dump condition, the resistivity of the cable drastically falls, which results in a huge amount of current flowing through a cable with low resistivity. This leads the cable to overheat.
Long wires are dangerous because of their size. Indeed, long cables have a greater resistivity due to their size. Resistivity of a cable is proportional to its size. The longer the wire, the bigger the resistivity. Since the resistivity is bigger, the temperature increases inside the cable. This causes the wire to heat and be dangerous. If the wire overheats, insulation might catch fire, and thus creating a big flame. Pushing metal objects into sockets is very dangerous or even deadly. The voltage of the socket is over 120 volts. 120 volts passing through your body is deadly. This is why it's dangerous to push metal objects into metal sockets. A consumer unit is a central dashboard with all of the switches of different electrical circuits of this house. It is connected to the fuse box so that when there is too much electrical devices in use, the electric flow is closed. This is a security that prevents a fire. The fuse box is a safety that manages the consumption of electricity. When too many electrical devices are in use at the same time, the fuse activates and the electrical current flow is stopped. The fuse box also counts your monthly consumption of electricity. The current is stopped by a device inside the fuse box. This device is called a circuit breaker. Basically, the circuit breaker is a device that prevents fire from occurring. Also, if the circuit breaker detects any disturbance or exterior connections not supposed to be, it activates. This means you cannot get electrified when touching a device connected to the general circuit. All of these devices are very important in a house because they assure the security of the people in the house.
Since their invention, light bulbs have tremendously improved our lives in numerous ways by giving us a clearer view of our surroundings during nighttime, wherever there is an electricity source. The first light bulb was an incandescent light bulb, and even though it is 100 years old, incandescent bulbs are still used. The way an incandescent bulb works is very simple. It consists of a tungsten filament positioned into a glass enclosure which prevents air or other substances to enter, creating a vacuum. An electric current passes through the tungsten filament, and due to its very high resistivity, it glows bright, providing light energy. The reason why tungsten is implemented in bulbs is because it's characterized by a particularly high melting point, in contrary of other metals. This prevents it to melt when the bulb is active. Bulbs normally have a stem or glass mount positioned to the bulb's base. This allows the electrical contacts to run through the envelope without gas or air leaks. Small wires attached to the top of the stem support the filament. Sometimes a bulb can contain an inert gas to prevent the filament to evaporate. Nowadays, people don't use as much filament bulbs because they are not efficient since their useful output light is less than half of the total electrical energy used to light it up. This means that the electrical energy not converted into light energy is converted into heat energy, which is a non-useful output.
To heat food, the microwave oven uses radiations. These radiations pass through the food and heat the food from the inside. But how are these radiation waves created? To create these very powerful radiations, the microwave needs to convert energy. The energy used to power the microwave is electricity. This task is made by a generator called a magnetron. Indeed, the magnetron takes the electricity and converts it into 12 cm waves. In the center of the magnetron there is a cathode, a solid metal rod. Around the cathode there is an anode. If this simple magnetron is switched on, the electrons would agitate in the cathode and move in straight lines to the anode and not produce any radiations. This is what happens on an old TV set. However, on the magnetron of the microwave oven, there are two extra bits. First of all, the anode has lines and holes cut into it. Second added part is a powerful magnet placed around the cathode. The magnet creates a powerful magnetic field. So when the electrons try to move from the cathode to the anode, they travel through an electric field created by the electricity and a magnetic field created by a magnet. Like all electrically charged particles that pass through a magnetic field, the electrons will be applied a force that will make them follow a curved path instead of a straight one. The electrons will flow in a circle in the space between the cathode and the anode. When the electron nips past the cavity in the anode, the hole resonates and creates a microwave radiation. To make the anode cavity resonate, the electron transfers its energy to it. The radiations produced by the anode are directed to a waveguide which is used to send the radiations into the cooking department. This is how the microwave converts electricity into heat.
One of the most common electric devices you will find in houses are electric water heaters. These devices convert electric energy into heat energy in order to have hot water for showers and other domestic uses. Water heaters are powered by 220-volt circuits, and the current passes through electrical resistance heating elements composed of nickel, chromium, zinc, and little quantities of iron. The heating elements are positioned one at the middle of the tank, and one at the bottom. A switch called thermostat allows power to flow through those elements. A thermostat senses water temperature, so that when the temperature drops, the switch closes, whilst when the water reaches the set temperature, the switch opens, preventing the electricity flow. Normally, the maximum temperatures water heater reaches are 55 to 60 degrees Celsius. However, increased energy-saving programs set the temperature to 50 degrees. When a hot water tap is opened, cold water enters through the dip tube positioned at the bottom of the tank. The dip tube is connected with a thermostat, so that when cold water passes, it activates the element at the bottom. As hot water at the top is used and replaced with cold water coming from the bottom, also the upper element heats up, thanks to its thermostat. When the tap is turned off, both elements continue to work until the desired water temperature is reached.
Into some river.